Hi all, welcome to our Mapbox live session today. My name is Karen Ellenberger. I'll be presenting a little bit about our search product today and talking about how you can configure this API for your use cases. So first things first, I'm going to start sharing my screen. So give me a second, bear with me as I noodle through some application windows, and then we'll get started so you don't have to look at this boring background for very long. So welcome all to our presentation today. Again, my name is Karen Ellenberger. I'm the product manager for search here at Mapbox. And today we're going to be talking a little bit about location search. So to give an intro of how this session will work, I'll go through some content. And if you have any questions at all, please drop them into the YouTube watch section. There's a comment section in there, and we've got some folks here that are helping out to take notes. And they'll be dropping those questions to me, and so I can answer any questions that you have at the end of the session. The session is also going to be recorded, and you can find it at mapbox.com/live after this presentation, and you'll be able to rewatch anything that you have questions about. So welcome. Let's talk a little bit first about how we're going to structure the presentation today. The first thing we're going to do is talk about the basics. Then we're going to go through 3 different use cases and how to configure the API specifically for your use cases. And then we're going to do a little preview about some very exciting things that we're building here in our labs. And I'm super, super excited to share this with everyone today. We are working really hard on a local search endpoint, and I'm thrilled to be able to share a quick preview of a very early version of this with you all today. So to get started, we're going to begin with the basics. I want to make sure that everyone is working from the same foundation of concepts and vocabulary so that as we move into talking about how to make specific configurations on the API, everybody knows the vocabulary that we're going in with from the get. So we're going to talk a little bit about what makes Mapbox's search and geocoding product a little bit special first. We work with open data. We are an open data first platform. We believe very strongly in the community and the importance of open data. But open data by itself needs a little bit of help. It's not commercially viable. And if you are building an application that end users are going to see and that you're going to be asking them to pay for, it needs to be a premium experience for them, which means that Mapbox helps take that open data, and we do a lot of munging with it. We do a lot of cleaning with it, deduplication. We make sure that it's as free of spam as we possibly can get it. And then we apply our many years of geocoding expertise in how you take that data and make it clean, accurate coordinates and good language experience for your users. We also focus on making a very customizable product. We are a platform. We give you Legos to build whatever you want for your users, rather than asking for control over what your user's experience looks like. We give you that control to build whatever app is the best experience for your end users. And that also means that our API is very tunable. Now, this is great if you want to build something that's very specialized for your users, but that means it can also be kind of a complicated product to work with. So one of the goals of today's presentation is to help everybody understand what the different configurations are so that you can use that tunability to make the best possible experience for your users. Another thing that's special about our geocoder is that we allow permanent storage of geocodes for enterprise customers, for addresses and cities. Whatever you get from that permanent endpoint, you can use, you can make derivative works with it, you can store it. It's a very powerful set of tools for enterprise customers. We are also built to scale. We do a lot of requests through our API. We're built for very high uptime. We are built for companies like the Weather Channel to use our tools and know that they're going to have reliability and fast service. We also offer support. You will get real human beings. If you file a request for feedback for the geocoder, the engineers that are working on the search product are the people who will actually read that request for support. So that's a pretty awesome thing about Mapbox that we think is very special and very important to us, is our ability to understand how people are using the product and to try and build a product that supports your use cases. So In the spirit of that, we've just released a brand new API playground. This is a big improvement. We are actually making live the tool that our engineers use internally for debugging and troubleshooting. We've just made a version for everyone who's not internal to also understand and play with our API as well. So in the upper right-hand corner of this screenshot, you can see there's a little cog icon. That icon leads to a pop-out menu, which is a GUI interface to all of our different API functionality. It's a very cool tool. I really suggest everyone take a look. It's at mapbox.com/search-playground. And if you'd like to leave us feedback, there's a little bug icon that goes to our GitHub repository. Please leave any comments, suggestions, bugs you find. We'd love your feedback about this. So now let's talk about some basics. Some of you may know all about this already, but bear with me for just a couple of minutes while I go over some basic concepts and ideas so that everyone is working from the same platform here. So what is geocoding? Geocoding is converting a human name for a place into a computer-readable name for a place, taking something like an address here, 1509 16th Street in Washington, D.C., and converting that to a set of coordinates that will allow you to place a point very precisely on a map. There are two kinds of geocoding that we work with here. We work with forward geocoding, which answers the question, where is something? Where is this address? Where is Starbucks? Any of these questions, that's a forward geocode, and that will return in the response a set of coordinates. An example of this would be in a standard search query where you have a search bar on a map and you want to find the potential matches for a user search query. This is a forward geocode that you're asking for. The other kind of use case we often deal with is called reverse geocoding, which answers the question, where am I right now in the world? This will take coordinates from a cell phone or from a geo IP provider and take those coordinates, and we will give you in response the name, the human readable name of a place. So an example of this would be Snap Maps, where they return the name of the city where you are right now. In this case, it's Washington, D.C. So users often ask, where's our app? We actually don't make an app. We make an API so that you can make an app. And this is an example of what an API query looks like. So we do have a set of libraries and plugins that we are providing for people to try and make their lives a little bit easier. One of the things that's on our roadmap this year is to make a new SDK that's a little bit more unified, that will give you a better experience as a developer and make your lives a little bit easier. But in the meantime, here are some libraries and plugins that you can access. The slide deck will be available, and these are links. You can also search for Mapbox GLJS and find a link to where you can get that repository. So where does search fit into the larger ecosystem? Search by itself is not always super useful, but what we do is help anchor user experiences on the maps, and we also help anchor experiences for users in Nav, which means that anytime your user is interacting with a map, if they're looking for a specific thing on the map, they need search to be able to narrow down the entire world of options into exactly the thing that they're looking for. And in a navigation experience, often a search interaction starts and ends a nav experience. You're starting from an address and maybe going to a restaurant downtown. And so you need to be able to search for both of those locations in order to get the user where they want to go. So now let's move into some specific use cases. The first one we're going to talk about is a use case where you might have users that have content that they want to tag, or you might have assets that you're tracking and you want to be able to return a human readable location name for where that truck is or where that package is sitting. So this is an example of how you might use reverse geocoding. Here's an example of one application where we are tagging some content, we're tagging some weather with a location. You're in New York right now, and so this is a reverse geocode. Here's another example of how this might look in an end use, which is tagging photos of where a user is. So a digital camera will provide a set of coordinates for you, but in order for that to be meaningful for your users, you need to be able to convert that into a place name. So there are two places on this screenshot where you'll see names. You'll see a city, a state, and a country, and then below you'll see a map with a location pin dropped on it. These are both places where you have a reverse geocode. So again, a reverse geocode answers the question about where am I? You're taking coordinates and you're converting them to a place name. And when we're talking about the reverse geocoding with the Mapbox Search API, the trick here is to be precise. but not too precise. And we're going to talk a little bit more about what the gradients here are. It's very important to have coordinate precision when you're doing a reverse geocode, but it's also very important to think about the kind of information that your users are looking for. For example, are they looking for single-digit decimal precision like this? Or are they looking for something much more precise like this? So how do you know? Which one do you pick? This level of single-digit precision will give you a state-level geocode, so Washington, D.C. If you need a relatively coarse level of geocoding, like you're doing weather for a city or weather for a state, single-digit precision will get you where you need to be. And what are the advantages of using this? This is very, very fast. It's very fast. It's very cheap. This is a great way to cut down on the amount of bandwidth that you're using, especially if you're using things like mobile devices or an in-car device where data is very important and very restricted. You probably want to stick with something that's relatively coarse like this. An example of visually how this would look is each of these points is about the level of granularity that you're going to get. This is Washington, D.C., and a 0.1 precision is going to get you somewhere on this map about the granularity of these dots on the map. So let's say you want to get something a little bit more precise than that. So if we move into 2-digit decimal precision, you're going to get something like a neighborhood, downtown Washington, D.C. So what this looks like on a map is about like this. This is, again, Washington, D.C. You're going to get about the level of precision of each of these green dots on the map. So good for a neighborhood or a town that might not be a very big city, but not great if you want to get very, very precise. If you want to get something down to the level of an address geocode, for example, you're doing a delivery service or you're doing a ride sharing service, you need to get pretty precise. So this is 6 digits of precision. This is what it's going to take to get you address level geocodes. And this is what that looks like on a map. So each of the red dots on this map is an address. This is an aerial image of the White House. So this 5 digits of precision is going to get you to this level of precision on a map. So again, it's important to be precise, but it's important to be the right precise for your use case and weigh out whether you need something like state level or town level or address level, and tune the geocoder to be at the level that you want it to be at in order to provide the least number of calls that you need to provide and also to be as fast as possible. So now let's talk a little bit about a different kind of use case. We're going to talk about search, how it works with nav. So examples of what might be use cases for this would be rideshare, where you are trying to get a driver, any kind of use case where you're trying to get a driver to a specific place. So one would be rideshare, another would be a delivery service like food delivery or package delivery. So one thing that we're really excited to share that Mapbox has been working on recently is called routable points. So when you're using geocoding to anchor a nav experience, you have a start and an end point, and you can set up our geocoder to be, now you understand the level of precision you need to get in your reverse geocode to return the address where someone might be standing at the beginning of a ride. And then you want to be able to get them to the doorstep of the place that they're going. So here's an example of what a nav interaction might look like when it doesn't go well. So this is an example of the Berlin airport. The point of the center of this polygon of the Berlin airport is about in the middle of the runway. So a nav interaction might send this person to a funny cul-de-sac at the top of the Berlin airport and then drop them off at the end of the road where they have to jump over a fence and then wander out onto the runway. And that's what kind of navigation experience you're sending your users on, which is not a great experience. Where you really want them to get is at the terminal at the bottom side of the screen, which is, in terms of distance and time, that's actually quite a distance from where you've dropped them off. So we have been working on how to solve for this problem, and we've created a secondary element in our address geocodes called a routable point. So this is an example of where the 2 different points might appear on a map. The first point is the routable point, and we're mapping you to the street that's nearest the primary address location. And then our primary address location is marked here on the map as well. So here's a difference in routable points versus no routable points. The image on the left is what it looks like when you don't have a routable point. We are sending you into the middle of this building past a fence. This is a navigable road in the middle. This is something that a garbage truck could go to or might be an appropriate truck route, but it's not going to be a place that you want to drop off someone on a ride sharing experience. So instead of sending them into the middle of the building to a loading dock, we're going to send them to the front of the building on the street that is associated with that address. So this is a great way to improve your user's experience if they're doing ride sharing or delivery services. So in order to enable this on the Mapbox Search API, you want to set an element called routing equals true. And this will get you an array. It is usually, right now, it's one coordinate, but it may also be multiple coordinates as we start to develop this. Currently, it's just one. I also want to talk a little bit about address interpolation. This is something that's really important to consider if you need very precise address locations. This is a way that we try and communicate with our users about our level of confidence in the accuracy of the address data that we're returning to you. This is an example of an API response to an address. And in this case, this is a response for a place named 740 Northwest 15th Street, Washington, Indiana. If you have a place type of address, you can look for an element called interpolated true. And interpolated true means that we are making a guess. We are missing some addresses, or the users are searching for an address that we may not have in our data, but we can make an intelligent guess about where it might be on the street. So interpolated true is just a flag to show that we've algorithmically determined where that address might be, but we're not 100% confident in where that location is. So there might be use cases where it is important for you as a developer to know about this attribute called interpolated and to be able to look for it to understand whether you want to return that address to your users or not. So now we're going to talk about a third use case, which is local search. And this is something that is one of our primary focuses at Mapbox on the search product for the rest of the year. This is something that when we started the search product, it was actually a geocoder, and all we were focused on was making sure that we could make pairs of coordinates to location names. But we didn't focus as much on the search experience. And now that we have a very, very good geocoder, we want to shift our attention to making a really good search product. And Mapbox was a mapping platform first and a search company next, unlike some of our competitors that started out as a search platform and then made maps. So we are really, really focused on how we improve our search experience for our users right now. So I wanted to give some tips. We get a lot of questions about how to tune the Mapbox API for local search. And I wanted to talk a little bit about some things you can do to improve it. And then I'm going to go into talking about some of the things on our roadmap that are especially exciting that are in this area. So here's an example of what a local search interface might look like. You want to be able to have autocomplete set up so that we can suggest to users some locations that might be interesting to them. And you can also set things like proximity to help prioritize the search results for local results only. This is also where Foursquare POIs really shine. We are very, very excited about our partnership with Foursquare. We've just finished loading the Foursquare data into search, and it is miles ahead of what our previous POIs were. So we're really, really excited about this. The other thing that we're working very hard on is being able to provide a really good, robust category search, which is also really important for local users. So here's an example of what a local search interface might look like. You just have a search bar, you might have some categories, and then you'll show people a list of suggestions that are things that are relevant to them and close by. So again, point of interest, we've just loaded our Foursquare data. This is approximately 3 to 4 times the number of POIs that were previously available in Mapbox. This is very exciting. We are already hearing a lot of good positive feedback from our users about how much Foursquare has helped with their search implementations. So I'm going to step back just for a second and talk about how our data is grouped so that we can help everyone understand a little bit about how our search features might need to be tuned in order to get you a good search. So we roughly group our data into layers from very, very granular things like addresses all the way up to countries. And it's organized in indexes that cross this entire layer. So all of the addresses are in one index, all of the places are in one index. So then you have to try and disambiguate about which of these addresses, which of these 1509 16th streets are you looking for? Which other layer is it associated with? So any kind of hints you can give us as the people trying to give you a good response, any hints you can give us about which layer you're trying to look at is very useful for us. So here's an example of what these look like in the API response. You'll have a section called context, and this context will show you all of the layers of data that we are dropping that pin through in order to give you that location. And what we're going to talk about now is how to give us hints about which data from these layers you want us to be returning to you. So it's really important to find the right context for your users and think about what your users are needing. And a big part of finding the right context is to think about what your users aren't looking for, not just what they are looking for. So an example of this, we return a score called relevance. And this is probably one of the most misinterpreted parts of our API. We know that it's confusing for people. We're working on updating our documentation right now, but I wanted to take this time to tell everyone a little bit about this relevance score. So what relevance measures is it measures the result and query text match. It's just a text match. It's not returning a relevance in terms of how prominent a feature might be in the world. It's giving you a text match score of 1. So if every letter of your query string matches what's in our index, you're going to get a relevance score of 1. So sometimes this can deliver some somewhat unexpected results. For example, here's a search for Eiffel Tower Paris. Well, we can see that we actually have 3 Eiffel Tower Parises. They are all relevance of 1. There's the Eiffel Tower in Paris, France. There's the Eiffel Tower in Paris, Texas. And there's an Eiffel Tower in Paris, Tennessee. And brownie points if you've been to the Eiffel Tower in Paris, Tennessee. All of these are going to return a relevance score of 1. But we suspect that we know where most users on a global search are going to want to be looking for. They're going to be looking for the one in Paris. However, you might have a user that's in Texas, and they really do want to find the one in Paris, Texas. So how do we make sure that we're getting the right one of these Eiffel Towers returned to your users? We have a couple of ways of doing this. We have one element called a proximity bias, and proximity bias works best when it's in combination with a couple of other features. So proximity bias essentially will return things that are both, one, relevant in terms of the textual match to the query that your users are passing, and then also geographically closest to a point that you pass that's called proximity. Another thing that you can use to help us figure out which one of these you're looking for is called a bounding box. This is a hard filter. Any features that are outside the bounding box coordinates will not be considered or returned in the result set at all. So bounding box is a hard filter, but proximity bias is a softer filter. So let's talk about how we do tie breaking. In our Eiffel Tower example from before, there are a couple of ways we can do this. The first one is to apply a country filter. If your users are in the US, if you're a ride-sharing company or a delivery service that only operates in metropolitan areas in the US, apply a country filter. Apply a country filter of the United States. If you're operating in Europe, you can apply multiple country filters, but you want to take out all of the options that are in India because your users aren't in India. Think about where your users are not going to be and make sure that you're filtering down the results. This is going to make the service faster, and it's going to provide a much better set of responses that your users are expecting. The second way to do a tie break is to use a proximity point. So the combination of a country filter and a proximity point is going to get you a much better set of results. And now let's move to talking about some of the things that we have coming soon. This is really exciting for us. We've been working on some beta, some early prototypes of some things, and we're excited to be able to launch these to some customers soon. If you're interested, look me up, and we're looking for some folks who are interested in testing this with us. So some of the things we have coming, I mentioned this a little bit earlier, we're working hard on some mobile and web SDKs. We hear from a lot of users that they would like to get a pre-configured SDK if it's on web, that they would like to have some features that are specific more for global search or can help them use GeoIP services. If it's on mobile, we can pre-configure the API to be set up for a local search experience specifically. So we're working on mobile and web SDKs, hopefully coming by the end of this year or early in 2019. Keep up to date with this on our blog and in our documentation for any more information about these as they come up. So an example of what this might look like in an early prototype, it looks like this. It will give you your search bar. It will give you some hints about using category search, things like that. So we also are working hard on improved local search. This is the #1 thing we get from customers. The request that we get from customers is improved local search. And this will the things that we're working on specifically, there are about 3 of them. And I wanted to show, I'm hoping this works, the videos of some of these features and how they might look. So the first one, we want our users to be able to use fuzzy search better and find place names using fuzzy search. So an example of how this might look is here. We have a video of searching for Home Depot. And we can see that we have results that are both Home Depot and the Home Depot. So this is very exciting for us. We have a whole range of fuzziness that we're going to be able to incorporate into this new local search. The next is to be able to do much more robust category searching. And this is especially exciting for us because we have built a directed graph category, which means that we get a little bit fuzzy in our category capabilities too. So this specific example is looking for noodles in Denver. So you can see you can type in pho and find soup, you can find chowder, you can find ramen. We are associating all of these related categories and returning results for any of those, rather than just limiting it to one search. If we might not have a lot of pho noodle places, we can suggest some things that might also be interesting to users that are contextually related, but might not necessarily be textually related. The other exciting thing about this, which is I just wanted to show this because it's kind of fun, we also will be able to have limited emoji support. So if you're looking for a bank, you can type in a money bag and get a set of results. And last, for a lot of the travel and point discovery use cases where someone might be trying to discover points around them, we are working on a functionality to be able to find points along a route. And this is also multimodal. So you'll be able to select different kinds of transportation that users might be interested in. So here's what a demo of this looks like. This particular example is for beer in Berlin. So you can set yourself a route across the city of Berlin and return beer halls that might be along that route. You can also in the bottom left-hand corner see where you can set your modality, which is driving or walking, or you can configure your driving route to take into consideration traffic as well. So this is a really exciting thing that we've been working on. So we're going to wrap up now. We really, really want to get feedback from our users. Tell us what you like, tell us what you don't like, tell us what you'd like us to build, because we really do want to hear back from you about what kinds of things you're trying to build, what kinds of experiments are you doing, are you struggling? Please let us know what we can do to help. We really do want your feedback. The best place to give us feedback is at mapbox.com/geocoder-feedback. This creates a ticket in a repo that our search engineers actually go through every single ticket and read them. So please let us know what we can do to help. We really do want to hear from you. And thanks, everyone.